Caddis Maximus here, this time with a review, quick teardown and look inside, as well as performance comparison of the Rockwell Tiger Saw, also known as the Porter Cable Tiger Saw, after Rockwell bought Porter Cable and then resold their power tool division to eventually Black & Decker, which is owned by Stanley now. And the Rockwell name kind of exists as Cheesy Tools, but what's kind of odd is they're one of the few manufacturers even today of true active counterweight reciprocating saws, and they're vibra-free. And I've been looking around, and it seems like the Rockwell vibra-free, Super Sawzall, the Makita AVTs, and the Skill Buzzkill are the few saws, and as well as some of the Milwaukee Fuels, that actually have active counterweights and are truly really low vibration. So Milwaukee actually came out with the Sawzall in 1951. Wow, long time ago. The Rockwells through the 60s, 70s, 80s, and eventually the Porter Cable Tiger Saw, which is what this became. The telltale sign is the orbiting switch that's right here on the side of the gearbox. It was really just the best competition. There were lots of Skill and lots of other companies through the decades also made, pretty decent reciprocating saws, but they weren't really on par with the Sawzall besides these Rockwells. Even this old 277, they had various models, 627, 677, and then all the Porter Cable models. They first introduced the actual name Tiger Saw when they started pinning these gray, and then they came with a little label that said Tiger. So real long time, surprisingly enough. Then they had slightly later models of these metal ones which had reversing switches. And one of the ways you can tell if a tool was really popular, even if you have a hard time finding information, is just when you look through Google Images. There's actually quite a few websites, Etsy and all these different places, little auction sites and these type of things, where quite a few of these Rockwells show up, telling you that quite a few of them were sold, and they're actually built pretty well because a lot of them are still running. This is a vintage unit, and it is pretty much 100% metal, even with the steel fan, 8 amp motor, so definitely pretty decent performance. And of course orbiting, and I think they were one of the first with an orbiting reciprocating saw, where Milwaukee was one of the first with a active counterbalance reciprocating saw. And then when Milwaukee ended up adding an orbiting function, it ended up being much more aggressive than the Tiger Saw, which is probably a good thing. There's some interesting features like these old ones. You could actually still use a side handle with your reciprocating saw, which I thought was kind of interesting. They do appear to use what is known as a swash plate or a special bevel plate in the finger. This allows the gearbox to remain narrow, and it was of course always a hallmark of the Sawzall. And it also allows the front neck portion here to remain relatively narrow and much easier to grab. It does have an all steel shoe with actually a rather thick metal bracket held on with 3 surprisingly large fasteners. You can see that they have a provision for even a 4th, but they found that that was even a bit too much. And of course it has the orbiting function. How the orbiting works is as the blade goes out, it makes a little arcing, it kind of hooks down and then comes back again, and there's just a special mechanism that just pushes up and down. So when you disable orbiting on any kind of a reciprocating saw, all it's really doing is lifting the back of the plunger so it won't touch and ride against whatever is causing it to orbit, giving you a straight cut. Some Sawzalls, such as the Milwaukee Sawzall, I should say reciprocating saws such as the Milwaukee Sawzall, sometimes still have a little bit of orbiting even when you turn it off, but you can of course always put the blade in upside down to ensure that you completely bypass those mechanics. Now, in my previous review of that DeWalt Sawzall, I was using a pretty poor quality blade, although my point was made because I used the same blade between all the saws. But somebody did comment about these Diablo Carbide Tip 3 TPI pruning saw blades, so I went ahead and picked one of those up, so the whole experience will be a little bit faster. And I actually haven't experienced these carbide tip pruning blades, so we'll see how quick it makes the cuts. And a quick example of orbiting. Let's go and actually turn it off and put it on manual mode. They actually stamp wood and metal, although you can use orbiting in metal and it will cut faster. It will be much louder and it will tear your blades apart, but it will cut pretty fast. They just generally recommend not doing it because it is pretty hard on the saws. Anyway, so we're going to do a straight cut. It will shake a little bit just because this has some vibration, but since it uses a finger and a swash plate system, the vibration is still inherently pretty low. better than the DeWalt, and this thing was made a half century before then. Pretty aggressive little saw. Now we'll put it on orbiting. What you'll see is the blade will kind of come around and make this kind of stabbing motion downwards, and that's really that's what the orbiting does, and that's what gives it so much more cutting performance, because it's the same thing as if you were like almost, periodically stepping on the tool with your foot. Here we are taking a quick peek at the electrical side. When I was looking at the DeWalt, of course, it was a 10 amp nameplate motor, and it only had a 10 amp switch on it. This is a bit more proper, and many tools today significantly overwrite the switches just so they can handle the surge current and voltages that come from big coils of wire. This is actually a 12 amp rated switch. I'm trying to get this in the frame. The motor is pretty decent. We can see that right here where we have some stamp welds. Actually, let me go ahead and zoom in a little bit. Here we go. We can see how the motor does have nice little stamp welds. This unit has had hardly any use at all. Even though it's discolored, when you run your finger across, you can't even feel a lip there at all. And these kind of commutators can be used until they're really gouged out. And they're actually special sticks that you can grind down. What I thought was kind of interesting is if we can get this to focus, is we can see the little stamp welds actually aren't very well centered. Come on now. Now there's a better focus. But they do put quite a bit of protection on the motor, including a little kind of a guide card to keep all the wires separated, and then they wrap it and varnish it. Although the field isn't wrapped, so it isn't quite as good a motor as some of those older Black & Decker and Milwaukee's, but still pretty decent. Milwaukee or Rockwell did make lots of tools with those kind of motors, but this is evidence that this is starting to get into the 70s, and they're starting to be a little bit more price conscious, but still just really well built. Brush guides are actually machined and broached, solid brass. Nice overrated switch. Overall, pretty decent back here. Here we are starting to get into the gearbox. If you're curious why I do these cuts, it's because it saves a bunch of time as opposed to just watching me undo a bunch of screws. And you get the same information. One of the things I need to show here, because it's kind of awkward with a long reciprocating saw to demonstrate, but I can kind of, if you look closely right here, you can see the orbiting action. When I pull the shaft in and out, see how the back end is going up and down. You can barely see it, but that's the orbiting action. I suspect that's why they have this odd top cover. This grease is actually surprisingly old. If you can put your finger on grease like that and barely any rubs off, you know it's old. So we're going to replace that. It actually has a nice felt seal here, double felt seals that look like they're in great condition, and really good flat machining between these parts. And that's really evidence when I took the top part off, because we can see all that sawdust and just not a single bit of it, not a single grain of dust has made it inside that portion. So actually pretty good job of sealing and showing that if you have really flat surfaces, many times you don't need gasketing. Just getting more into the gearbox, and finally got the two halves apart. I want to just point out we do have, of course, a nice little needle bearing in there. This grease is actually pretty torn up in this Rockwell. I've seen a lot of other tools that are pretty old, and the grease held up better, so we'll see. I'm going to replace all this grease with synthetic. It just seems that maybe Rockwell, with the motor not being wrapped and being, a little bit of budget cutting there, that they may have also been using just a little bit lower grade, a bit cheaper grease. And yes, if you're noticing, this looks a little bit strange. Why is that? The little motor pinion, a tiny little 6-gear. It is straight cut on this. It is not helical cut, but and then it is tiny. That thing's like 1/4 inch or something. Why is it kind of look like it's internal? Because it's really interesting. They're using, it's technically a spur gear, but it's being internally driven. So you could say it's like a planet gear, but it's not working like a planet gear because there's not multiple gear sets. There isn't actual planet gears. It's just the fact that the way they've tried to compact this, And to get a good leverage ratio, instead of having a bigger gear and making the gearbox drop down further, which is what Milwaukee does. Their gearbox actually drops down some from the motor just to accommodate a larger spur gear that they have to offset lower. What Rockwell has done is instead broached one where the teeth are on the inside like a ring gear from a Planet, but it's just being driven like a spur gear. What is an advantage is that the arc is this way, so that the arc of those teeth is going around the motor pinion like this, rather than standard gear teeth when the two arcs are touching tip to tip. So it actually, even though it's straight cut, it is getting a little bit more gear tooth engagement and reducing loads as opposed to an external spur gear. And I think that's pretty interesting. Obviously, this is pretty rare because the cut teeth on the inside of a ring is much more difficult than it is to cut it on the outside of something. Here's our little lever. We're currently in orbiting mode. When we disable orbiting mode, and this is how it works on all the saws, there's a little cam, there's a little foot that lifts up on the back of the shaft there so they can't actuate the orbiting mechanism. I did also want to point out that we do have our bronze oil light bushing in both the back and the front. It's interesting. This is like a large, obviously ground hardened steel square, about a 1/2 inch, but it's drilled to try to make it as lightweight as possible. And that's one of the reasons, even though this is not counterbalanced, still has reasonably low vibration, is because they've done a pretty good job at reducing the mass. And I liked the fact that it's a 360-degree surround bearing. So unlike the DeWalt, where it's primarily designed to have forces going in only one direction, this is supported on both ends, 360 degrees. So it's very robust, no matter whether you have the blade in right side up or upside down. What I also like is they have this through pin, which aligns this piece and the intermediate piece to the diaphragm. So when you take it apart and you reassemble it, it actually retains its a really precision alignment so that you can service it, but it won't potentially cause you any issues where, like on a lot of drills, they don't do that, and you'll have like the gearbox cantered a little bit one side or the other. And of course, it causes the gears to ride on high spots and wear out quickly. And a note to anybody who may be working on one of these, this pin right here is what this whole assembly, this is like an aluminum box that has the bearings in it that holds the front end. This is what this whole mechanism is pivoting off of. Milwaukee does something totally different when they have a spherical bearing. They have a very elegant design, the Milwaukee. This pin I banged on. This thing is in here really tight. This pin will have to be pressed out, which is challenging because it's on a surface that's tapered. So it makes it especially challenging because you're going to have a hard time really making sure that the part is on the table parallel to the direction you're pushing the pin. Very easy to think that it's flat, maybe set it on the side of the gearbox and it's actually tilted, and that's asking for things to shoot out in the press. They did make it a super tight fit, I understand, so that it won't come out, but banging on that with a punch, with a hammer, was hitting it hard enough to where it was like, you really need to press it out. Otherwise, you're going to need like a 2 or 3 pound fuller and really actually whack it quite a few times. If you try to set it on a socket, you're going to have to hit this so hard that the socket's just going to leave this big indentation right here around it. Really surprising that they have such a tight press fit. It hinders serviceability because this back half just is stuck. It will not come apart until we can lift this thing out. So it makes serviceability much more difficult, surprisingly enough. Another note, I did pull out the motor. We can see a little plug and like a little hole that they drilled where the rear bearing for the motor went. They actually do that so that it provides a little bit of relief so the rear bearings don't get quite as stuck, and it's actually a nice little feature. Many of these tools like this one will have these little spring-loaded washers just to provide a little bit of tension on the back of a bearing, especially when it has a little bit looser of a fit like that. And you just remember that the little fingers actually face towards the bearing. And I did find, I don't know if we can really see very well here. Yeah, you can see Japanese bearing. So that's pretty good too. Here we are to the cutting test. I'll start off with the DeWalt. Sorry about not doing a complete teardown, but that's kind of an annoying thing that you run into, even with parts explosions. Occasionally there'll be certain tools where there's like one portion that you have to get apart that ends up being a real hassle. And when you're just doing re-greasing, it's nice to have a grease needle because I can poke it in there and re-grease all the portions. Although, surprisingly enough, it's actually pretty rare to run in those situations. So I'm going to use this DeWalt again, even though I don't like it, just to show the performance of a standard modern reciprocating saw with no orbiting or counterbalancing or anything like that. And we are using my new 3 TPI carbide tip blade. Here we go. I gotta get a better. It's just so slow using this saw. And yes, I realize I made 2 videos essentially with the same cutting test twice, but I am using a much better blade. It's just amazing, just a small difference like orbiting can make, or a small engineering change like orbiting can make such a big difference in performance of a tool. And having it decades and decades ago would have been pretty handy. We got a little nub there. So you could actually hear it bogging down because of how aggressive this blade was, but it did pretty well. Surprisingly enough, this blade isn't seeming to cut a whole lot faster than that high-speed steel triple angle blade. And here we are with the final cut. Now, this is with a 6530 613 amp Orbital Super Sawzall. It is part of the cutting speed is a function of the blade stroke and of course the number of strokes a minute. And this is pretty aggressive at 1 1/4 inch stroke by 3,000 strokes a minute. And the counterbalance also helps reduce some of all this bouncing that's happening here. I mean, really, why would you... With this blade, that was like 3 times faster than either of the other saws. So anyway, I think that Rockwell saw is pretty cool. And I think that I do generally believe that the Tiger saws are okay. They just never really seem to, 1, catch on, and 2, they had some real quality issues later on when they're branded as Porter cable and just never really held up. And they didn't really innovate for a long time until Rockwell's name and their consumer divisions got resold a million times. And like 10 years ago, they came out with the vibration-free saw, which is pretty cheap. But once I helped somebody with one of those 1-ton Toyota pickup campers to cut off the camper and then turn it into a flatbed, and I couldn't really imagine using any other kind of saw. Anyway, I really appreciate everybody watching and subscribing. If you haven't subscribed, please do. Until next time, Catus Maximus out.